there is,
Sorry.
okay, whoops, that there is human-driven global warming and climate change going on. What the consequences are, which are a function of how much magnitude of climate change there is. What can we do about the problem, and how well are we actually doing today? And there we're going to look at Europe and the US, India, and then especially China. Okay. So starting off with global warming, climate change, the scientific evidence, what sets the temperature of the Earth? It's a balance between incoming sunlight, and what we're plotted here is the various bands of energy that are coming in, electromagnetic uh, radiation. So we know, of course, what's coming in from the sun is a bit of ultraviolet, a good deal of visible light, and that's where the maximum is. And there's a lot of near infrared as well. And what that does is that warms up the surface of the Earth. And of course, we're not sitting at 6,000 Kelvin, so we don't glow quite hot on the surface of the Earth. Instead, the temperature of the Earth is about plus 15 centigrade or so. That's the global average. So what goes back out from the surface of the Earth now is well into the infrared. And that's very different from what's coming in. So if we put carbon dioxide and water vapor and other greenhouse gases, methane, nitrous oxide, et cetera, they're going to block the outgoing part of this. They're transparent to what's coming in, but they absorb what's going back out, and they keep us warmer than we would be otherwise. All right, so that's basically the greenhouse effect. And from the natural levels of carbon dioxide and water vapor, we're actually 33 degrees centigrade warmer than we should be based upon the amount of sunlight we're absorbing. And that tells you the greenhouse effect is real. Anybody who denies it is simply just wrong about that. And what we're worried about is adding 1.5, 2 degrees or more to this temperature by blocking what's going back out here. Okay, so we know there's a natural greenhouse. We know the temperature and carbon dioxide and also methane track together going back 800,000 years. We can take ice cores from Antarctica going down 2 miles, and we can actually look layer by layer at temperature, carbon dioxide, and see, yes, carbon dioxide, if you have more carbon dioxide, you have more higher temperature, and vice versa. Okay, so that's global warming right there. Okay, so the next thing then is what's basically happening with global warming and climate change. All right. So back in 1896, the great Swedish chemist Svante Arrhenius, he was watching the industrialization going on in Europe. Remember, the Industrial Revolution started with Britain in the beginning of the 1800s. The US with the Civil War jump-started it here, 1870s, it really took off. And by the time you reach the 1880s and 1890s, the time of Arrhenius, he was observing that you were starting to industrialize throughout Germany and France and Scandinavia where he was. And he said, we're putting a lot of carbon dioxide out in the atmosphere from burning a lot of coal to make steel and keep us warm and do other industrial processes. I wonder what's going to happen if we were to double the amount of carbon dioxide in the atmosphere. So he did a paper and pencil calculation, which concluded there'd be about a 5 degree centigrade rise. All right, we're about halfway to that doubling right now. And we now have very sophisticated ways of doing computer modeling. And we have our computer try and calculate what's the effect of putting in certain amounts of carbon dioxide and water vapor and methane and everything else. And we can go back in time as well. We can calculate, does the computer model tell us a correct answer if we adjust these levels going back in time the way we knew they rose from the start of the Industrial Revolution? And the models actually show that Arrhenius was actually pretty much correct in his calculations. He's not that far off from what our computer models calculate today, again, calibrated based upon what we know happened over the last 150 years or so. All right. So we do our computer modeling today, and we come out with the conclusion that the rate at which things are going right now, we're likely to see 2.7, 2.8 degree rise in temperature. This is going to blow well past the hope for 1.5 degree rise and well, maybe if we don't do 1.5, a 2.0 rise. Okay. So the bottom line for how are we doing today is actually we need to do a lot better. All right. This is from the Intergovernmental Panel on Climate Change. That's a UN agency with many, many outside consultants, prominent scientists, climate scientists, who do reports every 6 or 7 years on what's going on with global warming, climate change. And this is what we calculate going forward to the end of the century. Okay. All right, so what are the adverse impacts? Everybody in this audience pretty much knows all about these things because we're encountering them already. All right. So we know there are more severe storms. A warmer atmosphere has more energy in the atmosphere. That's going to crank up these storms. We're going to see more Category 4 and 5 hurricanes, for example, converted from what might otherwise have been Categories 1 and 2 or 3. Okay, there's more flooding that we expect because a warmer atmosphere can hold more moisture. That's the way the relative humidity table works. So, of course, a warmer earth and warmer atmosphere means more evaporation. So there's more water in the atmosphere. So when it comes down on us, it comes down in buckets and we will have floods. What about droughts now? Well, if we're warmer and we go the same period between rainfalls, the warmer earth will evaporate its water faster and it'll evapotranspire. Water will go through plants as well. So we will tend to dry out between rainfalls. So it seems like a contradiction that we'll have floods and we'll have droughts. All right, but you can actually have both going on. Floods when it rains, droughts when it doesn't. Okay, so what are the consequences? We know about this. India in particular has to worry about heat deaths from heat stroke, right, as the temperatures start rising. And you also have more moisture in the atmosphere. You have a humidity problem that doesn't reduce either. All right, plants, crop plants. Actually, most crops that we have generated starting with the start of agriculture 10,000 years ago have seen a temperature range of only about 1 degree or so. They're not used to the kinds of temperatures we expect to see going forward. They don't like the excess heat any better than people do. So we do expect a significant drop in crop yield at the same time that global populations can be rising from today's 8 billion people to perhaps 10.5, 11 billion people by the end of the century. All right, with more droughts and drying up, we're going to see lakes and rivers and basically our freshwater resources disappearing, reducing there as well. Okay, and how are we going to support this greater human population with all these kinds of things going on? Floods kill lots of people from storms. We expect tropical diseases to spread, but actually what most people don't realize is ordinary diarrheal disease increases as well as temperature rises. You get more food spoilage and stuff like that. So this is a much less known problem that we expect. We know that carbon dioxide is causing ocean acidification. That's bad for coral reefs, and we're losing them in a major way. Okay, so overall, the effect on the biosphere and ecosystems is going to be pretty adverse. We expect a lot of species to become extinct, both on land and sea. All right, and the last thing we're concerned about is when you start warming up the oceans, anything that warms up starts to expand. All right, so sea level will rise, the oceans will get larger, and they have nowhere to go but up on land. So we expect to see coastal flooding, especially from storm surge, from these more severe storms. All right. So here's something that's very much concerns climate scientists these days, and that's the rise in sea level. You can see the plots here from tidal gauges going back all the way into the 1870s, 1860s even. Okay, and now we have satellite measurements for the rise in the height of the ocean. Okay, these are are considered the gold standard, the most accurate measurement. And the point is, it's accelerating. That's what we're worried about. So yes, most tidal gauges are in places like Europe, and in high latitudes, you tend to see greater tidal shifts over time, et cetera. But if we just simply plot lines, straight lines that go through, straight line for up to 1940, up to here or so, okay, or straight line up until 1980, you see what's actually happening is an acceleration. All right, so this is what worries us. In 2017, I saw a request for proposal from the U.S. National Science Foundation. They were looking for somebody or a group of people who could place sensors down in West Antarctica here. There are two glacial areas that they're concerned about. The Pine Island Glacier, the Thwaites Glacier here. The way these are situated is, of course, glaciers slide to the sea very slowly, but these glaciers are situated well above sea level. And the fear was that if you start eroding and eating away at the base of the glacier, the whole mess here could actually collapse and fall into the ocean. Then you'd have a phenomenon like what happens if you start throwing ice cubes into a glass of water. Well, the glass of water level is going to rise. You're going to cause the sea level to rise. So the concern is if the ice shelf, the West Antarctica ice shelf here were to collapse, we would see a 10-foot rise in sea level, okay? So the question was, there were concerns that these two glaciers here, which actually act like a cork in the bottle behind which the rest of West Antarctica sits, whether they might in fact be eroding away. And the answer we have, unfortunately, today is yes, they are. They're eroding a lot faster than we expected would occur. So we do have to worry about this. I mean, when people started talking about Antarctic glaciers back 25, 30 years ago, they said, well, there's a theoretical possibility we could have a real problem, but it's not going to happen anytime this century. Now the possibility exists that it could happen sometime this century. And that's a really dramatic rise in sea level. Okay, so what can we do about this? All right, so we have an enormously complicated graph here. And if you follow this graph and understand it, you understand how the US energy system works, right? So what we have here are the inputs of energy, the kinds that we use. There are three fossil fuels. The biggest one, of course, the input is petroleum or oil. And the lion's share of that goes into moving us from one place to another. Cars, trucks, trains, planes, buses, things like that, okay? Then we have natural gas. Natural gas, a lot of it goes to industrial processes, making fertilizer, for example. A lot of it is used to heat us up, keep us warm, residential, commercial, and a very large part of it goes into making electricity. Then finally, we have coal, all right? And basically, most coal goes to making electricity still, right? We tally up the three forms of fossil fuel, they account for about 79, 80% of all the energy we use, all right? In order to meet this climate crisis, we have to get off of that. So we have to really flip the energy system on its head. We have to go from 80% use of fossil fuels to zero. That's our challenge, and it's a huge challenge. So what's going to replace fossil fuels? It's going to be non-carbon emitting renewables. So you have solar, we have wind, we have hydro, we have geothermal, biomass. Here are your numbers. About 2% is solar today, 4% wind, 2% hydro, very small amount of geothermal. All right, hydro, geothermal are site limited. We're not expecting to see much of that. Biomass, that's about 5% today, but that's also going to be limited in terms of the amount of land we can turn to energy crops and things like that. So we have nuclear, and I'm going to ignore nuclear after this because nuclear right now, we have issues of safety. We have issues, actually greater issue of nuclear waste. This is controversial. We have concepts for new modular nuclear reactors, which may be sea changes in nuclear itself, especially in terms of safety and things like that. but they're still need to be proven, okay? Nuclear is actually a current part of non-carbon emitting energy. It's a significant part. We'd like to, or some people would like to see it grow. We can discuss that if we're interested. But basically what it's going to come down to is there are two forms of energy that are going to have to take over from fossil fuels, flip the whole energy system on its head, replace 80% of the energy we use today with solar and wind energy, okay? So we know what solar farms look like. The big industrial farms have seen a very dramatic decrease in price. We are now at the point where we're under $1 per watt hour of solar output. All right, these massive numbers of solar panels covering huge areas of land. That is a dramatic decrease. We're at the point where solar is actually now cheaper than coal in particular, and competitive with natural gas, the other major input for making electricity. Okay, so solar, dramatic decrease in price, huge increase in competitiveness, makes a lot of sense where there's a lot of sunlight. With wind turbines, what we're seeing larger and larger wind turbines, okay? The larger you are, the greater amount of area for capturing wind and the more efficient you become and the greater output. And that's been the tendency over time. The largest wind turbines now are 50% larger than what was in this picture here from Gretchen Baki's book, The Grid, 2016. This is just 7 years ago. We're getting up well over 11, 12, 13 megawatts for a single wind turbine. You're talking about hundreds and hundreds of households that can be supplied from a single wind turbine. All right. There's also been a dramatic decrease in the price of wind energy. But unfortunately, in the last couple of years, wind energy is running into a difficult time right now. Prices are actually going up by a bit. All right. So wind and solar, let me back up here and say they make electricity. All right. So one challenge we also have is if we're going to get away from oil and petroleum, gasoline, and stuff like that, we somehow have to be able to use electricity to replace oil. That's electric vehicles. That's a big challenge we face. How do we convert our vehicle fleet to all electric vehicles? Okay, so what do we need to see takeover by wind and solar? Continued cost reduction. All right, we hope that wind energy gets over its bumpy period and it can start going down again, especially with offshore wind. And the wind isn't always blowing, the sun isn't always shining. You have to have electrical storage for those periods when you're not producing from your solar panels or wind turbines. Okay, that's usually batteries. And that now takes you into the area of critical materials. And who controls these critical materials, all right? And one problem the US faces is China has locked up a lot of sources and a lot of production. So you've probably heard these names for batteries. What do you need? You need lithium, you need cobalt, you need nickel. Cobalt comes from the Democratic Republic of the Congo, has the lion's share of sources. It's often mined in horrible conditions by children and things like that. Bothers China far less than us. China controls much of the sources of cobalt there. Nickel mostly comes from Indonesia, and there are environmental problems with nickel mining as well. And of course, copper is everywhere. Copper's in wiring, so it competes with a lot of other uses for copper, like building new buildings and things like that. All right. Another thing we're going to need is a high capacity long distance grid. It would be ideal if we could somehow put up our solar panels where there's a huge amount of desert sunlight in the southwestern U.S. Okay, and ship surplus far east to where the major population centers are. Our grid right today cannot handle this. We're going to have to increase the capacity. We're going to have it work over long distances. We're going to have a smart grid that's able to move huge amounts of electricity greater distances than we're used to. All right. With there, if you want to increase your grid, you run into resistance, not in my backyard. And who controls the grid? It's electric utilities right now. And there's really no incentive for them to increase their grid just to let somebody else's sources onto this. I mean, even countries like China run into this problem. And utilities are cautious. They know that if there's some burp or glitch in the grid and the power goes out, they're the ones that the customers are all going to be screaming at. All right. So they require a lot of study and a lot of proof that if you put this big solar farm on, the grid can handle it and there won't be power outs and stuff like that. So the big problem is, yes, there are a lot of proposals to create new solar and wind farms, and they're having trouble connecting to the grid today. All right. So that's an operational problem that we need to solve. But ultimately, what we have to do, if solar and wind make just electricity, is we have to turn our entire economy to work on electricity. And we can make things simpler if we become more efficient in our use of electricity. All right. Then we won't have to add that much more solar and wind, new capacity, et cetera. So we talk about, can we make buildings more efficient? And you know some of the things you can do, and may have already been doing things like that. To put in a heat pump instead of, say, a natural gas heater or something like that. To put in LED light bulbs instead of incandescents. Those are ways of becoming more efficient. For transportation, it's electric vehicles. And for industry, there are three major areas that use a huge amount of energy: steel making, cement making, plastics creation. Actually, I should have added a fourth, fertilizer, but it doesn't quite fit in here. All right. One thing that's very interesting to people in this field right now is the idea of green hydrogen. Can we make hydrogen from water using electricity from solar and wind, and that way convert to petroleum? All right. So talking about transportation here, this one graph tells you everything you want to know about how to become more efficient. There's a little person walking, and walking at about 5 kilometers per hour, 3 miles per hour. And this is the amount of energy and the food that we consumes. All right. The bicycle is a wonderful invention. It allows you to go 4 times faster, all right, for about 1/3 the amount of energy. Okay. But what if you need to get around and not on a bicycle or not on your 2 legs? Well, here's a car, an intermediate sized car. Look at the amount of energy that it uses there, okay? A large SUV, that much more, obviously. Even if you start filling the car up, you would get, with 5 or 6 people in that car, you would still be using this amount of energy per person. Look at how much more efficient electrical vehicles are. Okay, there's your electric car with just one person. That much more efficient than a full gasoline car full of people. Okay. Start putting more people, and of course, the amount of energy you use is less. What about mass transit? Well, there's bus. Okay. Bus is relatively inefficient because it tends to stop at stoplights and things like that on the surface. It gets caught up in congestion, et cetera. The subway system is far more efficient than that, especially when it's full at rush hour. Okay, what about going long distances? Well, we have high-speed trains and we have airplanes. And notice that a relatively full-size commercial jet these days is still more efficient at moving people over a long distance than a car is. All right, that's the take home from this slide. All right, now getting to the last and most interesting part. How are we doing? And to look at that, you have to ask questions like, who are the major emitters, right? Who should be doing the most to try and combat this problem? So let's start first by plotting in terms of, by nation, who are the greatest carbon emitters, greenhouse gas emitters total. And China is number 1, all right? Here's the US, all right? But the interesting thing is, what if we plot based upon the number of people, divide out by how much does each individual produce, okay? China has roughly 4 times the number of people as we have in the US. So when you start looking at it from the standpoint of per person, we are the kings of emissions, right? We are number one. And then if you consider that our industrial revolution started long ago, that carbon dioxide out in the atmosphere, a large part of that is from us and from Britain. China only started around 1990 or so to put large amounts of carbon dioxide in the atmosphere. So you need to take this into account, thinking about who should be doing the most to combat climate change. And that's what goes on in these climate negotiations. So we can go down the list here, and I just want to point out here, deforestation is a major part of the net emissions coming from countries like Indonesia or Brazil, the Amazon, we know, all right? And there's actually a lot of reforestation going on in China and the US, and that's why there's actually a negative part that took away from the positive emissions here. But anyway, if we look at per person emissions, the US, China, like that, trying to get Vladimir Putin to do anything useful for the world, forget about that. All right. And it goes down here to India and EU. All right. So the Paris Climate Conference 2015, this came up with what we call nationally determined contributions. Each nation in the world set a goal to reach to be its share of trying to combat climate change. And that's what we're going to look at. How well are we actually doing in meeting these goals? So what was agreed to at the Paris Climate Conference? To keep temperature from rising above 1.5 degrees C, that's the aspirational goal, but an absolute goal of 2.0 by the year 2100. We should all be reaching peak emissions by 2025. China and India are going to be way, way beyond that, all right? And we should see by 2030 a 50% reduction, a 43 to 50% reduction. We get to set what our start date. So what our start date is. So all the nations chose a year in the 1990s when they had peak emissions, depending upon economic activity and stuff like that. So there's a little bit of fuzziness there. The worst fuzziness is these are not binding. These were goals that nations set. And in fact, virtually all nations are falling quite short right now. We just wanted to now, as we go to the rest of this, look at how badly we're doing. And is there hope? Yes, there is. The U.S. Inflation Reduction Act is a major step forward for the United States, okay? It could potentially allow us to reach this goal of a 40% reduction by the year 2030. If its promise is all realized. That's a big if. And that's something that we could all be part of as Americans, okay? So here's the reference, Urban Institute in Brookings. There is some good news out there, all right? As we move forward, are we taking this seriously? Will we take it more seriously as we go forward further? You know, the hope is yes, okay? So I just want to call your attention to this climate tracker. It's something that has been created with a whole bunch of environmental foundations, the German government, Rockefeller Foundation, among others in the US, et cetera. And what they do is they actually look at how nations are doing today and they rate them, okay? And that's what we're going to use for the final part here when we talk about how well are we actually doing, all right? So let's start with Europe. All right, Europe is under enormous pressure. Europe finally realized that it became far too dependent upon Russian oil and gas, okay? The huge fear last August, September of last year, before we went into the winter of 2022 to 2023, all right, was that the storage of natural gas throughout Europe, those tanks were well short of being full. And now Russia was threatening to use oil and gas weapons to leverage Europe's support, block Europe's support for Ukraine, okay? Fortunately, last year, Europe really lucked out. The winter was extraordinarily mild, and they used far less natural gas than they were afraid would be the case under a normal winter. And they managed to come through the winter very well, all right? Will we see another mild winter this fall? Well, they're better prepared. Their tanks are all full, their natural gas storage. And Germany created a whole bunch of natural gas terminals to import natural gas from other countries. All right. So to get off Russian oil and natural gas, you want to have sources from elsewhere. You want to electrify everything where you were using oil or natural gas before, which you now depend upon electricity. Europe is actually very fortunate that the North Sea is quite shallow. So it's actually an ideal place to be putting huge wind turbines. And they're doing this in a major way. There's an interesting quirk in the German electrical grid. The electrical grid is designed to go east-west. So if you're going to be bringing in huge amounts of electricity from the North Sea into North Germany, how are you going to get it to South Germany, all right, where there's a lot of industry? Well, actually today, it goes through Czechoslovakia of all things. And the Czechs are livid because what happens is there's already so much electricity going through Czechoslovakia. If you think of the grid as being like a highway, all right, there's a huge amount of cars going from North Germany to South Germany through Czechoslovakia. The Czechs can't get on or off whatsoever. So Germany is a prime example of where a nation really has to do something about its grid system. And we're going to be watching to see what they do about that. Okay, but there's a huge potential for wind in Europe. Okay, question, raised hand.
Yes, it's just me. You said we could do this during the program. It so happens I was in Germany last summer, and I noticed they have an extraordinarily large amount of windmills. When we drove, a lot through a lot of the country, and they're really, so I'm not sure if that's what they're attempting to do to deal with this, but there certainly seem to be a lot of them.
Yes, you're absolutely right. And if you go through the U.S. Midwest, you'll see that as well here in this country. Those are onshore wind turbines. Okay, they're ones that are already there. If you're talking about a huge increase in wind electric output, we're talking about putting these giant wind turbines, state of the art, still very new technology in the North Sea itself. That's a challenge. Offshore wind, putting wind out in the ocean is very novel today. That's where you're seeing a lot of hiccups in introducing this new technology. What they're running into is into supply chain, problems. They're running into the fact that interest rates are way up, inflation is up. So the planned wind farms that were planned a couple of years ago, they're now facing all these financial problems. And you may have heard that Ørsted, which is a major Danish company, putting in offshore wind, ocean wind, had proposals to put 2 major farms off in New Jersey and has now canceled those. Okay.
Interesting. And I see in terms of technology, Risha is raising her hand old school. So Risha, would you like to ask a question? I went the electronic way, but I see your hand is up.
Well, yes, I'm old school. One of the questions that I've been concerned about is if we get a substantial portion of the energy we need from wind, would that be taking sufficient amount of energy out of the wind to change our climate that way?
Okay. The theoretical physics maximum for extracting energy from wind is 57%. We will be nowhere near that.
Okay.
Right? Yes, you will actually decrease the amount of wind. All right. The reason why ocean offshore is so attractive is you don't have a lot of friction with the earth. You don't have trees, you don't have houses, and you don't have as much friction with the smooth ocean surface. A lot less friction with water as your surface. Also, the wind is much more continuous and reliable. You know that the land heats up more than the ocean does in the daytime. And so you have this onshore breeze and it reverses itself. The land cools off faster. You have the sea breeze going out after dark. Okay. So you can count on that. And that's what makes offshore wind far more attractive than onshore and far more efficient. And if you were to slow that wind down, well, what would the consequences be? We don't worry about as much about that as, potentially slowing the wind down onshore. Okay. In fact, there's actually been a wild proposal that we just dot the Gulf of Mexico with huge numbers of wind turbines, extract all the energy out of hurricanes that are approaching, the southern U.S. and make them far tamer. Okay, that's one of these wild, on paper ideas that people have had. Okay.
Thank you.
Okay, so what we're looking at with Europe is they have a really strong impetus because of this strong desire to get off of Russian oil and gas, to put in renewables that they can control themselves. Okay, so what they're facing is rising costs for new solar and wind. There's the inflation, the financing, and stuff like that. Interest rates are going up as well. Okay, there's also been resistance by people to putting in heat pumps in place of old oil or natural gas heaters in their homes. And there's also, you have a lot of EVs that have been sold. Norway is at huge incentives to buy EVs, and Norway has the largest fraction of their cars are now EVs, etc. Norway's a very wealthy nation because of all its North Sea oil. So it could put in huge incentives for people to buy electric vehicles. So you're seeing sales over 50% or things like that these days. All right. So you are encountering some resistance, but what about the overall rating? We hope the resistance can be overcome. The issues of rising costs and rising interest rates, et cetera, which people are going to finance to buy their EVs and heat pumps, they're facing that eventually those problems will diminish as well. So what Climate Action Tracker says about Europe, the EU as a whole, minus Britain, of course, with Brexit, is that their response is still insufficient. They need to do better than they're doing today. But they certainly have a lot of impetus behind trying to do better. All right, the U.S. Inflation Reduction Act. Climate Tracker also affirms what was reported in the Urban Institute Brookings study, that we actually have a chance of meeting our Paris 2030 goal of a 40+% reduction. If the Inflation Reduction Act meets its potential, we can get people to buy very large numbers of EVs and heat pumps and weatherize and do things like that, and increase efficiency as well as support the production of more solar and wind energy. Okay, so that part of the overall rating, we're actually almost sufficient so far as they're concerned. But the reason why I want you to look at this, if you're interested, is they look at more than just how is a nation doing in terms of its overall energy use and its overall emissions, but it's also looking at what kind of responsibility do we have as being the major historical emitter over time, okay? So the burden should be greater on us. It shouldn't just be, we meet the same standard as everybody else. So that enters into the overall rating. Should we actually be doing much better than just the Paris standard? Also, should we be supporting the installation of solar and wind in very poor nations to allow them to electrify? That's been part of major climate agreements that the wealthy nations of the world agreed to help finance the poorer nations of the world ability to meet their climate challenge. All right. So once you take those into account, in addition to, yes, we might not do so bad with our Paris goal, the overall rating for the US is insufficient. May come close to the nationally determined contribution, but we're still producing way too much oil and gas. We're ramping that up. And we have very poor financial support for developing nations, much poorer than Europe's. Okay. All right, so we're going to end up with India and China. The rating for both is highly insufficient. They're placing their economy, economic growth well ahead of reducing emissions. Okay, if you look at the goals for India and China, they're not really talking about 2030 to 2050. They're talking about further, you know. So if your goal was 50% by 2030, you go to China and India, they're talking about, well, maybe we can get to 50% by 2060. 2050, 2060. So they're not going to meet 2030 goals set out in Paris at all. And a major issue is both of them expect to see a sizable increase in the use of coal, which is by far the greatest emitter for global warming and climate change, and also increased use of oil, natural gas here. All right. India, if you go and look at what climate action says about that, they have a really serious concern over heat waves. They saw this past spring and summer. The monsoon that comes in June actually breaks the heat wave. So the biggest worry for India is the months of March, April, and May. All right. And you're now getting to temperatures and humidities in major urban areas in India where the risk of heat stroke is quite substantial for anybody laboring outside. Right. So India actually has a very, very serious concern over how far we're going to increase global temperature. All right. And actually has this very strong incentive to do more. All right. So we end up with China. There are questions about whether China can reach even the target that it's set. All right. A lot of it's going to depend upon whether China's economy goes into a major recession or not, because it's overbuilt they're non-performing loans for real estate and problems like that. Okay. There are also issues about the very stringent clampdown on COVID. It's made people cautious about spending, et cetera. That's carried through, even though they lifted all the COVID restrictions. But the question that's interesting to me, and I have to be very careful and say, I'm not a China expert by any means. I'm a scientist, and I follow, climate issues and things like that. I can't read Chinese original language Chinese at all. All right. I can talk like a 5-year-old. And to me, Xi Jinping being the supreme leader in China, he actually acts like he thinks he's the second and better coming of Chairman Mao. What is Xi Jinping looking for? What you have is a 70-year-old man whose aspiration is to make China the superpower, upcoming rising superpower of the next few decades. So that's going to be based upon economic growth. So, of course, he's going to prize economic growth. He also wants to have a world-class military, especially a blue water navy. You may have read that China is extending port influence all the way through the Indian Ocean up into Djibouti off the Horn of Africa. Okay, so the economic growth will give him the funds to build a world-class military operation. He wants Taiwan back, and he's told his military, be prepared to move on Taiwan by 2027. The US and China are loggerheads and opposition. In terms of economic competition, we hope it does not become military conflict in the Pacific. All right. So Xi Jinping at 70 is hoping to accomplish making China the economic superpower, upcoming military superpower, and things like that in the next decade. All right. By the time he's 80, or at worst 85. So is he going to put economic and military growth ahead of climate goals? All right. Yes, he wants to also be a world leader. And China is, yes, putting in more solar and wind than anybody else in the world. But China's economy is growing so much and is going to need so much more, and is so dependent upon coal right now, in particular. Can it increase the input of solar and wind even further? Right? That is a big question. Okay. Xi Jinping is a man in a hurry. All right. So I'm going to stop with that. If anybody has a crystal ball and can tell us what's going to happen with China and Xi Jinping, we're open for discussion at this point.
Are there any other questions or comments on this or the China or anything I think that we've heard tonight? And remember, please, you're muted. So if you have a comment or question, you will need to unmute.
Yeah, this to me is the interesting question. Where are we going forward from here? I mean, if we just talk about the US now, all the incentives in the Inflation Reduction Act, $7,500 to buy a new electric vehicle, right? You have to have enough income to write off $7,500 against it, or you can't use the tax credit or all of it. All right. So this is going to depend upon people who are wealthier, have greater amounts of income. And the big problem there is EVs aren't going to take you as far. We have this problem called range anxiety. What if we run out of a charge and we don't have a gas station in every corner? All right. We have to find a charger somewhere. And chargers are in short supply, even in places like California, where they have the greatest number. All right. So there's a lot of reluctance to go ahead and buy an electric vehicle at this point.
And if I can, so there was a question in the chat. Maggie New writes, what about water? We need clean water, not seawater.
Yes, okay. The issue with water back here, with higher temperature and more evaporation, our water resources are going to diminish with time. The problem with severe storms and dropping huge amounts of water in a hurry is the water runs off. It can't be absorbed. So you would think that if we have more severe storms and heavier rainfalls, that we would actually be able to replenish and grow our water supplies. But no, actually, that's not projected to what's going to happen as a result of climate change. So you put your finger on one of the major issues we face going forward. After climate change, if you were ask a poll of climate scientists or environmental scientists, what do you think after climate change, which is pretty much the consensus of being the greatest problem we face, what would the second one be? What would the second one be? It'd be loss of water resource, all right? Okay, and droughts and things like that. And people need water to drink, but so do their plants and their crops and stuff like that. You can make a very strong argument for the start of the Syrian civil war was a result of 5 years of drought in that region. And actually the projections, once you start going into region by region projections for what's going to happen with climate, temperature rise and evaporation and loss of water resources, that whole, conflicted area from the Mediterranean across the Middle East, from Israel, Jordan, Syria, across Iraq and Iran. All those areas are projected to see substantial temperature rises. Iran is already reaching issues with temperature and humidity rises to where the point that heat stroke is becoming a major issue in the summertime. Okay, but simply having growing populations in all those areas, a lot of those countries are seeing pretty sizable growth in population. Well, they have enough water resources to supply those growing populations. That's a serious question going forward. So that's a very important question. So I'm glad somebody brought that up.
And the second part of that is, what about the desalination of salt water?
Desalination, that takes energy. Okay. Yes, you can do that. Israel does a huge amount of that. We've learned from them, and we do that in Southern California, in places like San Diego and Los Angeles. We do that. You can do it, but that's going to be an increase in the amount of energy you need. Desalination is expensive in terms of money and energy.
Liz, can you unmute? I see your hand. You're muted. Wait, I'm asking you to unmute. Let's see.
Here we go.
Got it.
What about all these forest fires have to be exacerbating the situation too?
Oh, absolutely. Yeah. That's actually this is part of the problem. If you have a drought over a forest, it dries out, and a dry forest burns much more readily. Okay? So we're seeing things that are unprecedented. We're seeing forests and cities in places that are normally considered quite wet and relatively cool in the wintertime. We had record heat in British Columbia. All right. We saw temperatures up to 120 in interior British Columbia just a couple of summers ago. And if you don't have a lot of rainfall, you're going to dry your forest out very quickly, and it's going to be like tinder. Yes, and that is an auxiliary problem associated with climate change. So we can add that to the list here of more heat deaths, decreased crop yield, water resources, more fires.
Thank you.
Yeah, northern Canada's just not used to the kind of fire season it just saw.
Absolutely. And it seems to be getting worse every year.
Mhm.
Yep.
We know
definitely.
it because we see our sky turn orange, and we have to put on our masks, not just for COVID.
Right. I mean, the fact that we needed to wear masks here because of what was going on in Canada was unbelievable.
Mhm.
Yeah. And as Maggie says, the future for our children is very scary.
And the other issue about fire is, of course, that if you want to put it out, we use firefighting foam, which is one of the chemicals. Wait till the airplane goes by.
Yeah, most
the
of the
chemicals
firefighting is
that-
done with just pure water. And of
Okay,
course, it can't be ocean water, which is plentiful. It's fresh water, which is not.
right.
Right.
So they don't use firefighting foam on forest fires?
No, that's mostly reserved for urban type fires and stuff like that.
And submarines and
It-
airplanes?
it's much more expensive.
Yeah.
Okay,
Okay, yeah,
so if you're in an urban area, you're in a real hurry to put that fire out.
yeah, it's also used for airplanes and submarines.
Yeah, on board. Or if plane catches fire on the runway or something like that, then it's from the outside. Something damages the fuel tank.
Oh, it's just about 6:30. So, Albert, thank you so very much. This was an excellent presentation. As I shared with you, we do record these, and it will be on our YouTube channel. I know I heard from two people who were unable to make it, but we're hoping to catch it at another time. So that is available, and I thank you for your time and certainly for your knowledge, because this was really an incredible presentation, and I appreciate you giving it to us. So thank you very much, and Michael, thank you for helping to arrange this, as always. And I will see you all next month for, I don't believe we have a CCC program next month because of our anniversary party. So those of you on the screen, mark your calendars for December 6th. We will be celebrating the 12th anniversary of Georgetown Village. And we hope you'll all be there. And if you need transportation, let us know. And we'll have the food, the entertainment, and the fun. All you got to do is join us. And Albert, you're welcome to come. We throw a good party.
Okay, thank you. It was my pleasure to be here today.
Well, thank you very, very much. Have a nice evening, everyone.